Hello friends, now we define what is the angular velocity and angular acceleration. So let us suppose that a particle moves on a plane curve such that at time t the particle is at point P and at time t plus del t the particle is at point Q. Let us suppose that there is a particle which moves on a plane curve such that the particle is at P point at time t. After del t time, this particle is at point Q. Suppose that a particle moves on a plane curve such that at t time the particle is at point P and after del t time the particle is at point Q. Let us suppose that a particle moves on this plane curve at time t the particle is at point P. After del t time the particle reach at the point Q. Let us suppose that O be the pole here, OX be the initial line, and we suppose that the polar coordinate of P point be are theta. So angle XOP, this is equal to theta here. This is the vectorial angle of P point with respect to the initial line OX. Let us suppose that polar coordinate of Q point be r plus del r and theta plus del theta. These are the polar coordinate of point Q. So angle XOQ, this is equal to theta plus del theta. Now we find here the angle POQ. So angle POQ, that is angle XOQ minus angle XOP. So we know that angle XOQ here theta plus del theta minus angle XOP here theta. So this is equal to theta. So we find here angle POQ, this is equal to del theta. You can see here, let us suppose that a particle which moves on this plane curve, let at t time the particle is at point P and after del t time the particle is at point Q. Let us suppose that the polar coordinate of P point be r comma theta and the polar coordinate of Q point be r plus del r and theta plus del theta. We know that angle XOP, this is the vectorial angle theta, and angle XOQ, this is the vectorial angle theta plus del theta. So this angle is here, this is del theta. Now we find the angle POQ. Angle POQ is equal to angle XOQ minus angle XOP. So angle XOQ is here theta plus del theta and angle XOP is theta. So theta plus del theta minus theta is cancelled out. So angle POQ is del theta. Now we find here angular velocity. So angular velocity, that is equal to limit del t tends to 0 and displacement in time del t divided by del t. This is the angular velocity. We know that velocity is the rate of change of displacement. So angular velocity is equal to limit del t tends to 0 displacement in time del t divided by del t. Here we take here angular displacement. We take here this is angular displacement in time del t. We know that here angular displacement is del theta divided by del t. Angular velocity is equal to limit del t tends to 0, angular displacement in time del t divided by del t. That means rate of change of angular displacement in time del t is known as angular velocity. So angular displacement in time del t is given here del theta. Now we taking here limit, so we get this is d theta upon dt. So angular velocity is here theta dot, that means d theta upon dt. Again we find angular acceleration. So we differentiate this d theta upon dt with respect to time. So we get here d2 theta by dt2, and this is the angular acceleration. Thank you.